Hi everyone, we are going to talk about de Moivre's theorem today. Right? Basically, de Moivre's theorem only works on polar form. Alright, so what is de Moivre's theorem? It is simply r cis theta to the power of n to give you r to the power of n cis n theta. And bear in mind that de Moivre's theorem only works with polar form. Yeah, in order to use this de Moivre's theorem, you must convert exponential form into polar form or even Cartesian form into polar form. Right? So what comes under de Moivre's theorem? You can actually use de Moivre's theorem to work on a few things. Okay, you can use it to evaluate n roots of a complex number, that is one. You can use de Moivre's theorem together with binomial theorem, okay, to express, okay, cos n theta and sin n theta in the form of cos theta and sin theta, and can even use these two theorems, again, de Moivre's theorem and binomial theorem, to come out to simplify an integral expression that is given to you and then integrate it accordingly later on. Okay, so let's do n roots of a complex number. So what to note over here, you have to take note that all roots, okay, of a complex number are of equal length and they divide the complex plane into equal size regions. So to put it simply, all roots that are of a complex number must have the same radius and it must have the same separating angle. Let's look at two examples, alright? One is the slightly easier one and another is what you usually see in ways. Yeah, so the first example says I have got 1 plus I to the power of 6 equals to negative 8i. Note that root for this question is actually 1 plus I and it shouldn't be negative 8i. Okay, so root is always the one with the power. Yeah, so solving this means, okay, or finding 6 roots of a complex number for this means you are supposed to look for sec 1 up until sec 6. Right? So in order to look for these 6 roots, you will have to work with polar form, okay? Because I told you earlier, for n roots of a complex number to be found, you will need to have all these roots to have the same radius and they must have the same separating angle. Right? So knowing that 1 plus I is the first root, I got to simply convert this 1 plus I into a polar form. How did I get to 2 cis 45 degree? I simply went with 1 square plus 1 square and I square root it, and that would give my modulus, or I call it my radius, which is some sub2. And how then did I get my 45 degree? I went with the triangle. There are two equal right angle triangle that you must remember. The first one looks like that. 45 degree, and 90 degree, you have got 1 here, you have got 1 here, you have got sub2 there. And knowing that tangent inverse 1 over 1 is equivalent to 45, that is how I got my 45. Okay, so the first root simply says sub2 cis 45 degree. Yeah, so how do I get the remaining 5 roots? Note that all these 6 roots, because I look at power of 6, all these 6 roots has got the same radius. So you will see sub2 all over. How then do I tell the remaining arguments or the remaining angles? I got to simply add with the same separating angle all over. So how do I decide on my separating angle? It is always 360 degree divided by the number of roots. So for this case, it is 6 roots, hence 360 degree divided by 6, which will give you separating angle equals 60 degree. So for that, my second root would simply be sub2 cis 105 degree. Why? Because 45 plus by a 60 degree, I get 105 degree. And what about the next root, which is the third root? It will simply be sub2 cis 165 degree, because again, I added with the same separating angle. And we do the same to the next root where you will see 225. What do we usually want your angle to be in? We want it to be in the principal argument. And what is the principal argument? We want our theta, our angle, to go from negative 180 degree to 180 degree. So that being said, this 225 doesn't fall in range anymore. So how do I get it adjusted? You got to simply have this 225 degree to minus by 180 degree, and that is when you will get it shouldn't be 180 degree, it should be 360 degree, and that is when you will get negative 135 degree. Yeah, so negative 135 degree, when you add 60 degree to it, that is when you will get negative 75 degree, and again you add your 60 degree to it, that is when you get your negative 15 degree. Note that this sec 1 and sec 6 that I got has got no specific order. Whichever come first, whichever come next, doesn't matter. Alright, so this is one simple example where the first root is given to you. What happened if I were to give you a question like this? Okay, read the question carefully. It says, find the cube roots of 1 plus Z3i. So what exactly is this? You should know to form an equation like that. Yeah, because it is cube roots of 1 plus Z3i. Hence, it says Z to the power of 3 cube. Okay, cube root, hence sec to the power of 3 equals to 1 plus Z3i. So what am I supposed to do next? I am supposed to convert 1 plus Z3i into polar form. Why? Because De Moivre's theorem only works with polar form, right? So this 1 plus Z3i that I got to convert into polar form, but bear in mind that 1 plus Z3i isn't my root. I am trying to look for my first root, and the first root should be here. Alright, so how did I get 2? Again, it is 1 square plus Z3 square, and I square root it. That is when I'll get my radius to give me 2. How then did I get my 60 degree? Again, I made use of a right angle triangle, but this time around, instead of 45, 45, 90, it is now 60, 30, 90. Opposite 30, it is 1. Opposite 60, I should have Z3. And opposite 90, it is A2. Tangent inverse Z3 over 1, it's equivalent to 60 degree. Alright, so that is how I decided on the polar form for 1 plus Z3i. What is next that I got to do? I will need to be applying De Moivre's theorem. So what is De Moivre's theorem one more time? It is simply r cis theta in bracket to the power of n equals to r to the power of n cis n theta. Hence, power of 3, when you move over to another side, it would simply give you 1 over 3. Correct or not? So 2 to the power of 1 over 3 is what I got as my radius. And cis 60 degree multiplied by 1 over 3 would simply give me 20 degree. And by writing this correctly, you are getting 1 mark for the right root already. So how do you get the remaining 2 roots? 2 roots because observe over here that I wanted the cube roots, hence there are only 3 roots, okay? So it is 2 to the power of 1 over 3 again. 2 to the power of 1 over 3 again. What is the separating angle for this case? 360 degree divided by 3 because we are talking about 3 roots. Hence, 120 will give the separating angle. 20 degree plus by a 120, you will get a 140. 140 again plus by a 120, you are going to get a 260. You're right. So 260 minus by 360, that is when you get negative 100 degree. But is that the only way? Do we add all the time? Not necessary. You can also subtract the separating angle. So it is 20 plus by a 120 to get me 140. It could be also 20 minus by 120, which is the separating angle, to get to negative 100 degree. Negative 100 degree. Alright? So note that we always have our angle to be in the principal argument. Right? So that is how you get your 5 marks for this particular question. Alright? What happened if I were to ask you for this? Sec to the power of 4 plus I equals to 1. You are correct. Okay, it is actually sec to the power of 4 equals to 1 minus I. You're going to simply rearrange it and then convert this 1 minus I into polar form. And what would that be? You will probably be shouting your answer. It is Z2 cis. Note this, you have to check quadrant. What quadrant is this? This is in the 4th quadrant. Yeah, and 4th quadrant in the sense you are going to get negative 45 degree. And note that this Z2 cis negative 45 degree that I got wouldn't be the root yet. I'll have to be applying De Moivre's theorem, where I should be writing Z2 cis negative 45 degree to the power of 1 over 4. Work on this accordingly. That is when you will get your first root. And separating angle for this case would be 90. Why? 360 degree divided by 4, that gives 90, right? So accordingly, you will get all your 4 roots, alright? So that is your De Moivre's theorem. What about binomial theorem, or we call it the Pascal triangle? You will see a triangle in such a way where you will have the sides to always give you 1. The first row has got 1 and only 1. The second row will give you 2 ones. And the third row, how did I form? Again, the sides must always be 1. How did I get a 2? It is 1 plus 1 to get me 2. What about the next row? Again, 1 to start, 1 to end. How did I get 3? 1 plus 2 is a 3. 2 plus 1 is a 3. And accordingly, you will develop a never-ending triangle. Yeah. So what is the use of Pascal triangle or binomial theorem? It is for you to expand brackets accordingly. The first row is for you to expand a bracket to the power of 0. The second is to expand brackets to the power of 1. And the third is to expand brackets to the power of 2. Yeah, so let's try one. Okay, let's try one. We have got this. Alright, let's just say I have got a 1 plus I to the power of 2, for example. So if it is power of 2, these are the numbers that I got to look at. It is 1, 2, and 1, right? So what should I do? Okay, it is 1 that I put, minus 2 that I put. Oh, shouldn't be minus, sorry, my mistake. It should be 1 that I put, 2 that I put, and 1 that I put. Alright, so what to do next? This 1 is what I have taken as the first term, and plus I is what I have taken to be the second term, right? So I'll go in such a way. 1, what's the first term? I'll go with increasing power, 1 to the power of 0, 1 to the power of 1, 1 to the power of 2. If you have gone with increasing power with the first term, your plus I, which is the second term, must go with decreasing power. Hence, it is I squared, I to the power of 1, and I to the power of 0. Yeah? So what should I do next? Okay, simplify this accordingly. The first would simply give you I squared, and the second part would simply give you 2I, and the third would be what? 1. Simplify this. That is when you will see I squared is equivalent to negative 1. I hope you still remember. You will get 2I accordingly. Did I expand this correctly? You can always check, okay, by using, the way that you usually expand a power of 2 bracket. 1 plus I to the power of 2 is simply 1 plus I times 1 plus I. Expand this accordingly. That is when you will get 1 plus I plus I plus I squared, which is equivalent to 2I. Alright? This binomial theorem of Pascal triangle would be useful when you are expanding brackets of higher power, probably power of 3, power of 4, power of 5, and accordingly. Alright?